Right, welcome to the third lecture. In the first two lectures, what have we talked about? The mathematical world of signals and systems, right? And then we went on to the language of signals and systems, right? We did the very basic language of signals and systems. What were some of the key terms in there? क्या क्या हमने discuss की थी?
सिग्नल सिस्टम कहते हैं
Transform,
Discrete.
transform, continuous time, discrete time, impulse, which some common signal shapes, impulse, step, right? Yeah. Convolution, critical, it will show up again and again. After that, we went on to क्या था second part हमने क्या कर रहे थे? Signal basics, right? So we started familiarizing ourselves now with the basics or basic understanding of signals. And what did we discuss there? We said, okay, we will try to define some broad classes, right? And what were the broad classes we looked into? They were based on some questions that we asked, right? So what was the first question we asked? That was convolution, right? So in terms of classifying signals, we said yes. So first question was, is the x-axis continuous or not, right? So the answer to that question led to two broad classes, continuous time and discrete time. In fact, your whole book is divided by that. Okay? So some chapters are for continuous time, some chapters are for discrete time. They are often interleaved. But a whole chapter like I think chapter 3 might be for discrete time, and then chapter 4 is a continuous time repetition of that. Like that. Yeah? So two broad classes. Or kya tha? What else did we ask? Is the y-axis also discrete? So that led to the case of analog versus digital class. Yes? Okay. For this course, by the way, we don't really go too much into digital part. We stay up to discrete time or continuous time. Okay? That part is very easy to go into if you need to. Usually it comes up in a course called digital signal processing. And it also shows up partly in your instrumentation where you will work with samplers. Yes, so you will know more over there, but what we study applies here without any issues. Okay, third question. Yaad hai? This is just quick revision. Hmm? Repeating pattern. Okay, so yeah, repeating pattern. So if it did have a repeating pattern, we call it periodic. Yes. What was the condition to prove periodicity analytically, mathematically? क्या थी condition? Anybody remembers? So if xt, ये तो आपको पता है ना, we will be calling our signals, our collection of data or information, will be mostly writing it as xt, yt, so on. Yeah. This is the x-axis, the signal itself is on the y-axis, yeah? So, if xt is to be periodic, what was the analytical proof we needed for that?
I think basically xt आप ब्रैकेट के अंदर t plus capital T कर देना वो equal to same चीज हो जाएगी
t plus capital T. So there exists a constant which we will call here capital T. It's not a variable. This guy is a variable. There exists a constant capital T for which this holds. Is this definition complete or something missing? For all T. So if we don't do that, what will happen is you might find a signal where x5 is the same as, let's say you have it for T equals 10. x5 is the same as x15. But x6 may not be same as x16. Yes. So periodicity requires कि हर point ने अपने ही distance के साथ repeat होना है. Yeah. So this peak here has to repeat after t. This middle point here has to repeat after t. So every point, right, in one cycle has to repeat after t. So that means this has to be for all t. Yes. And then of course, if that holds, then you can always prove that xt is also equal to xt plus 2t, right? And it's also equal to xt plus 3 capital T. Yes. So that is the idea of fundamental period, the minimum one, because if t is a period, then 2t is also a period, okay, of the periodic signal. Then how do we make it unique? The unique is the minimum set, the minimum size, yes, that repeats. Okay, so this was a quick revision of this one. Fourth question. Okay, that was probably fifth, but yeah, one of the questions. Good. Random or deterministic. Yeah, so we looked at this, of course, this one. So is the signal random or deterministic? Since we are not going into random processes or random signals in this course, I won't go too much into the detail, but it doesn't have to be that the parameters are random. The values could be random also, okay? So then it won't look this smooth. But this is a good example to show that randomness does not always look rough. Yeah. So about this course, we don't go into random side. Okay. For this course, we stick to deterministic signals. Yeah. We can extend, and actually we do extend when I teach the random processes course. That's a graduate course we teach here. I build on what we teach in this course. Okay. But that's a separate topic, so we won't go into that one. Then we stopped somewhere here. We said, okay, we want to be able to see, okay, does the signal have some sort of energy, energy, finite power, and we talked about why they are needed. Yes. So why was that? I gave the example of measures. We like to measure. Yes. So or summarize some indices. So मुल्क की परफॉर्मेंस कैसे समराइज होती है किसी कंट्री की इकोनॉमिक परफॉर्मेंस जीडीपी यस स्टूडेंट की कैसे होती है और ओवरऑल सीजीपी इस पे आप हंसते हैं ऐसे ही होती है ना या shouldn't be the only measure, but we start with that often. Yes. So okay, measures are important, we saw that, and two measures. And again, these are not the only measures. Yeah, there are a lot more depending on the applications. But I want to give you the idea of the common measures that we use. One of the measures is energy. So what's the energy? You take the signal, you take its absolute square and find the area under that. Okay, that is one measure of a signal's properties that we will call signal energy. Yeah. We had a good discussion on why is there a square, why is there absolute. If you have forgotten, I can just remind you. याद है किसी को why? Firstly, why the square? So I had mentioned. Firstly, this is what happens. Why don't we just use xt? If you don't square it, there will be signals, many of them that will whose areas will sum to 0, and you will not get any meaningful result from that. Yeah. That was one thing. Absolute square, because we want to allow complex values as well. Yes. So absolute square is different for a complex number. For a real number, absolute and square will both make it positive. Yes. Then somebody asked towards the end last time, why square? Yes. So we have other measures also, other norms also, pth norm, else norm. We have so many more. Yeah. Square is often the most analytically simple. Okay, let's say if we were to remove the square from here, xt, we remove the, let's say, just make it absolute square. So we just use it absolute. Let's say we wanted to make it positive. Yeah, you know that the modulus is a discontinuous function, right? So it's not analytically very nice, Yeah, इसमें एक discontinuity होती है at t equal to 0. The square often leads to smooth functions whose derivatives exist, whose integrals exist. So we don't want to come up with a measure which is hard to measure. Okay, so that's it. A lot of what we do, as I said, is based on experience, is based on understanding, is based on our need to have some measures. फिर उसके बाद there are complicated measures in a lot of what we do these days. We need the zeroth norm of a vector, and that's very hard to work with, so we replace it with the square norm and work with that and get an approximate solution, because again you have to have something which is analytically solvable also. So from here on we will say a signal that has finite energy, we will call it an energy signal. Okay. So what is it saying? The total area under the absolute square of the signal. If it is finite, then the signal is energy signal. Yeah. So which one do you think has finite energy or is an energy signal? So what are we saying? Total absolute square area under that signal, if it is finite. Yeah. कौन सा लग रहा है वैसे roughly?
पहला वाला finite.
First one लग रहा है. It seems like asymptotically dropping. So it seems like from here at least. The second one keeps on going. Yes. So of course that cannot be an energy signal. It will lead to infinite energy. But is the second one possible in reality? Keeps on going forever?
Not really.
Depending on
Nahin.
the source.
So it's a conceptual construct. It can be a limiting case, but this kind of situation will not occur in reality, where a signal keeps on going forever and then the energy, the area under its absolute square becomes infinite. Okay, but we will see that in a bit. But yeah, from here it seems the first one is an energy signal. Now many theoretical signals do not have a finite energy, as you saw just this one. You say okay, it goes from minus infinity to infinity. It's so easy to say it. पर कहाँ से आएगा? कौन जाने? इतनी यूनिवर्स में लिमिटेड है ना चीज, पावर यहाँ की. So anyway, since there are theoretical signals that do not have finite energy, we need another measure. Yeah, and that comes in the form of energy per unit time, which is from basic physics is power. Yes. So then we have this notion or concept or measure of power. Yeah. So energy per unit time. And how do we define that? Now, how have things changed from the energy formulation? क्या क्या changes नजर आ रहा है?
लिमिट लगा दी और 1/t कर दी.
1/t कर दिया. Yes. And then we calculate the limiting case as t goes to infinity. The absolute square, the area under that, divided by t. Yes. So you have to see. You take the energy. Okay, right side पे part here.
एक period का.
Per unit time. Yes. This t is not the period yet. It's just it goes to infinity, so it's any t. Yeah. But we will convert it into the period for periodic signals later. Okay, so this we will call the power, and from here on we will say a signal is a power signal if its power is neither infinite nor 0. Okay, it's just our requirement. So
सर 0 हो सकती है.
नहीं हो तो सकती है, लेकिन अगर 0 हो तो you cannot call it a power signal. Okay, so it's the classification that we are talking about. Infinity or 0, then it's not a power signal. Yeah. So let's see some statements. You can just review them later at home. Think about them. There are signals that are neither energy nor power signals. Okay. So maybe a good assignment to look for some signals that don't fit either of these classes. Okay. Then an energy signal can never be a power signal. Okay. A power signal can never be an energy signal. Okay. So if you think about these, I'll let you look into these on your own. They make sense from these formulations here. Okay. So if there is, let's say there is an energy signal, and we're saying it cannot be a power signal, or the third line, can anybody argue why any of these is correct? Let's say second or third statements में से कोई भी आपको समझ आता है?
सर एनर्जी सिग्नल में ये बात थी ना कि क्या कहते हैं,
फॉर्मूला देख लें. So you can try with these formulas, start with an energy signal, and you will end up in most cases dividing something infinite with something finite, or something finite with something infinite. Okay, and that will lead you to understand, okay, if it is energy, then the power either power should become zero. If it is power, then the energy should become infinite. So I'll let you do that. But we have this variation if you know that the signal is periodic. Remember when we talked about classifications of signal, we said that once you are able to classify, then you can develop tools for that class. Yes? So we have already classified what? Continuous time, discrete time. All these formulas I have written are for which class, by the way? ये जितने अभी एनर्जी पावर के लिखे हैं, is it for continuous time or discrete time signals? Continuous time. Yes, I am using integrals. Yeah, xt, t is continuous. If I had to go to discrete time, which we do, the only variation would be mostly be replaced by summations. Yes, so we are already developing tools for different classes. Now a further subclass within continuous, for example, is whether the signal is periodic or not. A discrete signal can also be periodic or not. That's a further subclass. So here, if it is periodic, then the formula for the power becomes simpler. You see, no more limits. Yeah. What's happening now? How is this formulation different from this one? So in one case, you have Ex limit t goes to infinity 1 over t minus t by 2 to t by 2 xt absolute square dt. Yes, this is the general formulation for calculating the power of a signal. Now once you know that your signal is actually periodic with period t naught, this thing simplifies. Yeah, and it becomes, you have the period, so you do 1 over t naught, and over one whole period you get the area. Yeah, so how is it different now? Basically, remember when we discussed periodic signals, we said you only need to study one period, right, and the rest is the same. Yeah, so overall, whatever energy per unit time you are going to have in the whole signal, that should reflect in one period also. So within one period you should have the same energy per unit time, क्योंकि उसी पूरे ने repeat होना है, ऐसे ही. So we don't need to bother about the whole signal now. Just take one period, एक period है, yes, t naught. Find the energy in that period. This is the formula. Divide by length of the period, yes, which is t naught. So you get a simplified version of this. Now this is general. This applies to all signals, continuous time. If discrete time, then we'll have to get summations and work with that. Yeah. This one applies only if you have established that your signal is periodic. And notice how much simpler this is. No limits, nothing, but a simple ये. एक period, just over one period, find the area, absolute square of the area, and divide by the length of the period. Now this is again the power of classifying, right, and developing tools for subclasses like that. Yeah. So, okay, this we have looked at. Another measure that is often derived from the power is called root mean squared value. सुना है इसका? RMS कहीं सुना आपने? हाँ भाई? Already आप लोग you were working with these things, yeah? So basically you were finding the power of your input or जो भी voltage है या current है, IRMS, VRMS ये कर रहे थे ना? Where did you apply it by the way?
सर वो AC का DC
AC,
level.
yes, yeah. AC का DC level यानी you find some measure of the AC that represents it. वही बात जो हम कर रहे हैं, yeah. So RMS is simply the square root of the power. That's it. Yeah? Root means squared value. So this just to let you know the link between these. So I want you to take your notes, paper, pencil, and try to characterize. This is now practice little bit, yeah. So I want you to characterize this signal. Put it into classes. Yes. So, for example, is it continuous time or is it discrete time? Is it periodic? Is it not periodic? Does it have finite energy or does it have finite power? Can you try that? Continues, T after the other. It goes on. Usually, see, when we draw a pattern like this now, अगर हम उसको zero करना हो ना, if you have to show that it's zero, we will bring it to zero and then draw a straight line and end that line. ऐसे जब finish होता है, it means it's still going. Yeah? So, of course, the first question is rather simple. Is it continuous time or discrete time? Continuous time, right? Does it look digital or analog? So doesn't look like there is any discretization along the y-axis. मुझे तो नजर नहीं आ रही पूरा value ले रहा है ऐसे ही है ना?
Analog.
So it doesn't look like it's digital, yeah. So it's analog. Good. Okay. Is it periodic?
Yes.
Yes. What's the period?
2.
2 units, whatever that unit is. Good. So up to that you are right. Now, does it have finite energy or does it have finite power? Yeah, find that energy find that.
Finite power होगा.
Energy का formula याद है ना? For it, Ex was simply absolute x t square dt over the whole range of the signal. Yeah. So I think without calculating you can guess that the energy is infinite. Yes. क्योंकि वो negative parts will become positive also absolute square. Okay. If any t goes on forever, so it's a theoretical construct. It is definitely going to, in this case, there is no asymptotic drop. So yeah, energy is this calculation. The area under the absolute square of this thing is definitely gonna show up as infinite. So it's not an energy signal. Does that imply that it has to be a power signal?
Yes.
No.
No.
I mentioned that. You will find some examples. Actually, maybe I'll show you one later. A signal can be neither. Okay. So automatically I'm assuming canal. Right? If it's not energy, okay, that's one thing closed. Now you have to check, is it a power signal? What's your line of attack? कैसे solve करें? पहले तो try करें. You have everything you need on the board. Yes. And you just need a little bit of warming up. अच्छा ये चीज़ आप लोग MP101 वगैरह में भी सब कुछ कर चुके हैं by different names, right? Functions होते थे वहाँ. भूल गया. कितनी सदी हो गई है. कोई निकाल ले पावर तो मुझे बता दे.
Zero पर ही है. नहीं. हाँ ठीक है. सही है.
अभी आपको मैं इसका तरीका बताऊंगा, जवाब बताऊंगा तो आई थिंक यू विल लाफ. कितना इजी है ये. हो रहा है. I just need a number for the power. One. Okay, so I want one number. आप हो जाए कुछ हो. कंसेंसस से बस निकाल लेंगे जो वो मेजॉरिटी कहेगी वही कर देंगे. डिसाइड मैथमेटिक्स बाय मेजॉरिटी क्या है. हाफ सही है. मतलब मुझे खुद पता नहीं है ऐसे जवाब. मुझे याद नहीं पिछले साल पढ़ा. टाइम भी लगेगा. So I will check of course. आप लोग अपना आया थी ना, आपका वन है. कैसे ऐसे नहीं करना. जी सॉल्व किया. कैसे सॉल्व?
पहले 1/2 किया.
1/2 क्यों किया? क्योंकि आपने वो. Yeah, so that's the right way of solving this. Of course we have a general formula for power, but it would be very unwise to try this guy here. Yes? Why? Because it is periodic and the period is 2. So definitely go for the easier tool that has been developed for you to make things easier, right? Now many of you will still try the first one. फिर आप कई example लंबा था क्योंकि वो infinity का limit हमें लेनी पड़ी. But you don't have to. That's the thing. Always find the class that best suits you. और उसके tools use करें. Yes, so firstly, yes, of course, the period is 2, so you need 1/2 here. Area का क्या करें? Okay, so which period did you take?
1 minus 1.
-1 to 1. Yes, and you need xt absolute square. Yes, now you are in luck because this is basically going to be 1 here. So let's see. If you look at it, do you agree with that or no? What is it saying? Yes, it's not energy. That's fine.
4/3
Period
तो नहीं
is
आती.
2.
4/3 तो नहीं आती.
चले अभी देखते हैं ना. अच्छा, it's period from -1 to 1. This has only over one period. We have to choose the period. Why did I choose this period? कोई बता सकता? Well, I could have chosen 0 to 2. Now that's where practice comes in. Yes, knowledge of the field, how comfortable you are with the idea. Because it's so simple in that part. देखिए वो x t equals t, ये फॉर्मूला बनता है ना. अब एब्सोल्यूट ऑफ t स्क्वायर यानी t स्क्वायर, उसका इंटीग्रल तो आता है सबको. t टू पावर n का फॉर्मूला क्या होता है? t टू पावर n या x टू पावर n का क्या होता है इंटीग्रल? x n प्लस 1. तो पावर हो जाती है, एक बढ़ जाती है और डिवाइड बाय n प्लस हो जाता है. राइट, unless the power is -1. Yeah, उस केस में फिर वो log पे चला जाए. So here xt equals t. So the formula really simplifies. So you already know t naught is 2. So you have 1 by 2. Yes. Then you need area -1 to 1. That's the period. And xt square in that period. Xt equals t. Yes. So I can replace it. It's a real number. So absolute is just the same number itself. Positive. T square is the same thing. T square dt. Now this becomes 1 over 2 t n plus 1, which is what? T cube over 3 from -1 to 1. ये तो आप plug in कर सकते हैं. Yes? हो जाएगा ना? Limits plug in कर दें. Let's see the answer. मुझे उधर से पता नहीं. Okay, so it was 1 by 3. Yeah? तो किसी का आया सही मेरे नहीं आया. आप नहीं आ गया. It was वो क्या कहते हैं? It was fast. जवाब आपने जल्दी दिया. सही है या नहीं? Fast है. Was it right? Okay. So clear? कोई है इसमें confusion? But what are the principles we are learning here? कौन सा? ये वाला? ये वाला? Yes. See, this would be much harder to solve. Okay. Now we already have, of course, you don't run away from a hard problem, but it is unwise to solve it if you have a simpler solution. Now the signal was periodic, yes. So we already have a simpler version of this for periodic signal. So make your life easy. Yeah. Yes, if it weren't periodic, I would have to analytically इतना आसान नहीं है इसका ये निकालना जवाब. Yeah. You would have to do piecewise modeling. Different pieces की आप modeling करेंगे, उसका आप area निकालेंगे सबका, and then you will see that it will be complicated. It will take more time. So that is the thing I want to bring home here. Don't start with the first formula that comes to mind. Okay? Always see the characteristics of the process, of the signal, the information in the problem given to you, and then see, okay, I know this, this and this about it. Which of these is the most efficient formula or approach? Yeah? And this requires practice. Okay? Now many of you will tell me after the finals and after the mids that I knew it, I knew the topics, I knew the problems, but I made blunders in the exam. For me, blunders are lack of practice. Okay? So आप बताएं हम आपको timed exam क्यों देते हैं? घंटे का mid हो गया, 1.5 घंटे का, final 3 घंटे. Why do we give you timed exam? हाँ पूरा दिन 6 दिन 12 दिन नहीं देते. So let's say you have a cook, you ask him to make tea, and he takes 3 hours. Does he know his art? Is he comfortable, good at it? No. So we give you timed exam because we want to see how much comfortable you have become with this topic. Yes, and wo aayega through understanding the basics, summarizing the basics in your own way, and then practicing them. पहले 2 step भी काफी नहीं है. लेकिन if you don't do the first 2 steps correctly, the third efficiently नहीं हो सकता. Practice आप randomly नहीं कर सकते. You have to know what concepts you need to practice. Yes. So for that you need the first 2 steps. Reading the book, going through the slides, collecting the key information in your notes. Many of you don't make your own summarized notes. You say we just wrote during the lecture and we went through it. वो तो बहुत कुछ बोल रहे होते हैं ना. Every lecture, ये जो एक पूरा lecture है ना, often it can be summarized. इसके जो key points होते हैं ना, maybe 1/3 of the page, key points. If you're writing more than that, and you have not been able to extract the crux और इसलिए पूरा कोर्स जो है ना वो कोई 9-10 सफ़े होता है सही जो कॉन्सेप्ट होता है राइट सो मेक दैट हैबिट डोंट गो थ्रू ये आप लिखें जो लिखना है ये आप पास वैसे भी स्लाइड्स पड़ी हैं बुक भी है मेक अ हैबिट टू print the relevant chapters or sections of the book go through the book and उससे आपका lecture से क्या होगा we uncover links that may not be very obvious in the book yeah so note them also then summarize for each topic in just a small part of the page the key things अभी तक क्या थी key thing for example क्या था यहाँ पे energy और उसमें so we saw that for periodic cases power has a simpler formulation right then we saw that an energy signal cannot be a power signal a power signal cannot be an energy signal right so these are some key and then we also saw that signals can be neither of them yes so these are key baatein which you have to be able to do and then of course this kind of practice will come in handy so okay let's try this guy थोड़ा hard हो जाता है yes so is it firstly just characterize it okay so can somebody help me characterize it is continuous time
नॉन पीरियोडिक लग रहा है
नॉन पीरियोडिक
एनर्जी सिग्नल
लग रहा है बल्कि है भी जो है वो it says T right so looks like energy signal yes or no थोड़ा asymptotic drop है नहीं लग रहा energy let's see so it's dropping asymptotically we will have to see first it's not periodic modeling इस तरह के मॉडल को क्या कहते हैं piecewise yes किया होगा calculus वगैरह piecewise functions notice I'm just now replacing what you learned in fn or ft by xn and xt functions ही है ना signal अब हम क्या कह रहे हैं the data we have collected is a function of some parameter that will be time that will be atoms that could be space whatever so this is a piecewise definition yes so in the first piece that is between -1 and 0 the function is constant at 2 in the second piece it goes to e minus t by 2 there is a third piece which we are not showing वो कौन सा है
less than 1
राइट वाला तो हम शो कर रहे हैं t greater or this लेकिन t less than -1 जो पूरा है ये हम शो नहीं कर रहे often in piecewise definitions we skip the parts that are zero so क्या हुआ convention है assumption है yes what is the assumption things not shown here are zero other ranges not shown here the value is zero क्योंकि it's just redundant to write those also इस केस में तो मसला नहीं है लेकिन in many cases there can be several sections that are zero so it's easy to just skip them yeah so okay let's see the energy thing then what's happening here xt absolute square we wanted to take right since it was piecewise the integral became piecewise yes first piece was -1 to 0 there it was a constant 2 square just simply balance में limits डाल the second was 2e minus t by 2 e to power x का आता है integral e to power ax का भी आता होगा yes so that is what we have used here so then you put 0 to infinity yeah and notice because you will get e to minus t thing infinity would lead to 1 over e raised to 0 when you put the infinity limit डालेंगे ना 1 to e raised to 0 आएगा e raised to 0 is 1 so 1 by 1 is 1 so it will become easier to solve anyway it just leads to this इसमें कोई मुश्किल मैथ भी नहीं है इसके अंदर ठीक है. By the way, I do give in the exams वगैरह ना इंटेग्रल में डाल देता हूँ, ठीक है. एटलीस्ट आपको ये पता होना चाहिए कि इंटेग्रल ऑफ dx इज क्या होता है.
dx हो गया.
Integral of d of x is x. Fundamental theorem of calculus, right? Okay. ये तो आपको पता होना चाहिए. फिर ये आपको पता चाहिए कि इंटेग्रल ऑफ let's say xn is xn plus 1 over n plus 1 unless n is equal to minus 1. Yeah? तो ये एक दो पता होना चाहिए. बाकी जो e के हैं या कोसाइन साइन के वो मैं दे देता हूँ. This course is not about testing that again. You have been tested in that quite heavily. कितने कोर्स हो गए मैथ के, 3-4 तो हो चुके हैं ना. So I don't want to retest you in that. Just लेकिन आप अगर उसमें अच्छे होंगे तो you will do faster. Yeah, you will go faster. So and we say since energy is finite, this is an energy signal, and this cannot be a power signal because it is an energy signal. Now notice here that this can also help you answer what we said, that an energy signal cannot be a power signal. Why? Because notice, in an energy signal, we're not saying it's periodic or not, so we cannot go here. Yeah, we have to stay in the general formula. In an energy signal, this part will always be finite. Yes? Even though t is going to infinity, इसका भी तो t जा रहा है ना, लेकिन the areas adding up are not enough. They are just finite. ठीक? Convergent series बन रही. So this will always be finite by definition of energy signals. Then you will be dividing it always by something infinite. Time तो चले जा रहा है. Yes. So if you divide something finite by something infinite, what do you get?
0.
0. And we said a power signal is a signal that has neither infinite power nor 0 power. Right? So you are able to prove that statement now. इसी तरह बाकी भी prove है, कोई मसला नहीं. Right. So application of the this thing, the periodic thing, we studied periods. So this is a very important result. You will use it very often in this course. So I just put it here as an example of this thing. So what did we say? An xt signal is periodic when if there exists a t, capital T, such that xt equals xt plus t for all small t. Yes? Okay. Now, what is the period of cos theta? Cosine function है ना, तो उसका क्या होता है?
180.
Pi में बता दो. 2 pi. Yes? So cos theta plus 2 pi is cos theta. Right? यही होता है ना? So let's make it more interesting. Let's say you have cos some constant times t. Now this is my xt. Okay? This is now xt. What is the period of this? क्या है? So your signal is xt is equal cos omega naught t. So firstly, is xt continuous time or discrete time? Then is it discrete or continuous along the y-axis? Continuous, because cosine can take सारी values लेता जाता है. Yeah, we are not limiting it. Okay, is it periodic? We think so, yeah, because cosine is a periodic function. Fine. Now what is the period of ये बताएं. इस समय आप बता दें जहाँ constant है theta 1 to be know it's 2 pi. Yes. What's the period of cosine omega naught t, where omega naught is a constant, t is the time parameter. Right? इसका period क्या होगा? Try करें paper pencil. I already gave you the key. For any xt to be periodic, there must exist a capital T, yes, such that is same for all t.
So same
क्या आएगा?
same 2 pi.
2 pi होगा. Okay, that's one answer. 2 pi plus omega. Okay, उसको आप अपने इसमें टेस्ट करें ना. अपना जो claim है ना, it's good to start with some claim. Fine, test it here. अगर इतना easy हो तो फिर तो फायदा नहीं कुछ देने का, right? So try it.
सर सवाल क्या था?
What's the period of this
सही है.
signal?
सर 2 पाई होगा
Okay.
क्योंकि कॉस है, कॉस तो फिक्स्ड होता है इसलिए आप
Okay. So let's see. What do we need from here? Cosine omega naught t should be equal to cosine omega naught t.
प्लस 2 पाई
No, for the general case.
जनरल.
I had a new marker. Anyway. So it should be for all t. Agreed? That's what the definition says. Yes? Okay. Now you are saying the period is 2 pi. If you put
अब
2
थोड़ा
pi
सोचना
here,
पड़ेगा.
अब सोचना पड़ेगा. यही तो मैं कह रहा हूँ.
करेक्ट.
अब थोड़ा सा आपको recalculate सोचना पड़ेगा ना थोड़ा सा. If you put 2 pi here, yes, what do you get? What do you need to put something else here?
एक मिनट. 2 पाई ओवर ओमेगा नॉट. 2 पाई ओवर ओमेगा
ओमेगा
नॉट.
को क्यों चेंज करेंगे? देखिए, that's the idea. Let's say you understand functions, right? So what's the function? Xt equals cos omega naught t. Omega naught is a constant in this function. Yes. If you are to write xt plus t, you are changing, replacing t by t plus t. So you will replace t by t plus t. Omega naught will stay there. अगर आप इसको ऐसे लिख दें omega naught t plus t, so that's a rookie mistake because then you didn't change the time parameter. The time parameter has to replace itself. Yes, यही बनेगा.
Yes.
So that is the formulation. Yeah. Now think about it. What do you need here in t to make this the same as this?
2 पाई ओवर ओमेगा नॉट.
2 pi over omega. Okay. So let's try that. You have cosine omega naught t plus 2 pi over omega naught. If your claim is right, then this it should become this for all t. Yes, let's see if your claim is right. So it is cosine omega naught t plus 2 pi. Yes, it is cosine omega naught t. ऐसा ही है. ठीक है. So of course cosine has a period 2 pi, but when you have this omega naught t here as a function of time, okay, and there is frequency is omega naught, then the period becomes even smaller. Okay, so it is 2 pi by omega naught. So cosine omega naught t has period 2 pi by omega naught. What you are used to, by the way, is having omega naught equal to 1. वो जो आप कहते हैं ना कि उसका पीरियड
फ्रीक्वेंसी
2 pi है, वो आपको आदत हुई हुई है omega naught 1 लेने. So you are right, but in the more general case, when omega naught is not 1, the period is 2 pi by that. Correction factor आ जाता है. Okay, ये समझ आया कि नहीं आया? देखिए, this is the requirement for any signal to be periodic, any continuous time signal to be periodic. We said, okay, we have xt equals cos omega naught t. Then we saw to get this, we will have to rewrite it like this. Now looking at it a bit carefully, we realize that we will need to get rid of omega naught here to get a 2 pi here. थोड़ा सा इसमें सोचना आता है, but once you have done it, the reverse is very easy. If I tell you that, if I claim that the time period of a cosine omega naught t is 2 pi by omega naught, and if you had to prove it, you would just put that here, yes, and get exactly this answer, and you will say, yeah, okay. So the proving it once I tell you the answer is much simpler, yeah, but getting here, okay, it's not that hard either. So let's get back to that thing, and we'll reduce the size here. If I can find how to grab this. And back to our slides. Yeah, so you can show that cosine omega naught t has period 2 pi by omega. Now this result, कुछ result होते हैं जो थोड़ा सा memorize कर लेना चाहिए. It's not a big deal. You have proven it. If you forget it, just recall how you proved it. But from here on, we'll just assume it to be known. Just ये याद रखें. You know that the period of cosine is 2 pi. Yes. Just tell yourselves that was for the case of frequency 1. Yeah, if the frequency is not 1, instead it is omega naught, then I have to correct it by making 2 pi by omega naught. Why exactly this value? Because of this proof. Yes. So from here on, we will always assume that cosine omega naught t is periodic with period. So now quick question. What is the period, let's say, of cosine pi t?
टू हो जाएगा.
2 pi और pi.
2 pi और pi क्या निकला?
2.
2. Okay. So now you should be able to use this result. Okay, एक दफा prove कर लें, समझ लें. But then some results are so often needed that it's good to have them on your fingertips. So cosine omega naught t has period 2 pi by omega naught. 2 pi आपको पहले ही पता था. Omega naught, this frequency which is not 1 hertz now general है. So divide 2 pi by that. Yeah. So here omega naught is pi, so you had 2 pi by omega naught, which was pi. So you, of course, you had this. Now I can put anything here, and you will be able to find the period. Yeah. Okay. Any questions so far? So I won't start the next topic. I will just give you a trailer, and then we will actually do that. इसमें कोई what we did today, क्या क्या किया आज हमने, continue class किया, mostly energy and power, and then I let you practice a little bit, just so you understand that these things need very careful understanding and practice. जवाब बहुत easy नजर आता है भाई, ठीक है, right? Well, वो पहले signal का जवाब, when you get the answer you feel like yeah sure, पर हुआ किसी से भी नहीं है, so it's fine. But with time you should start getting to the answers. अगर अभी से 1-2 हफ्ते बाद, 3 हफ्ते बाद, 4 हफ्ते बाद मिड भी आ गया, फिर भी ये नहीं हो रहा, something is wrong. Yes, so you need to work on that at that stage. So next topic, I will just give a trailer, and then we will actually start from the very start there. This is it is trailers के आगे गए, आपको trailers के भी trailer आते हैं, एक सीन आता है 4 सेकंड का, अभी उसका trailer आता है, right? Lots of money, so of course makes sense. Yeah. So signal basics. This will be the second module or section in signals. Yeah? पहले में हमने क्या किया था signals को?
Class.
Broad classes देखी हमने, yeah, and then we established which classes apply to this course, and then we worked with some practice problems in some classification, right? The second part is about operating on signals. I like to call it messing with signals, yeah, just doing something with them, yeah. By the way, what is that thing that operates on signal? इसको क्या कहते हैं हमारी लैंग्वेज में? Anything that messes with signals.
Disruption, interference.
Okay. What else? So it does some operation on the system.
Missing, so missing का मतलब काम करना उसमें.
Now just with normal language लिखा है ना, operating on it, doing some operation on it. Yes. So in our language that's a system. Yeah, operating on that. So we will look at some signal operations. And these operations we will look at are the operations that often happen in systems. जब signal system के अंदर जाता है, तो system उसके साथ क्या करता है? There are a lot of things a system can do, but we will look at some of the basic ingredients. Yeah, and you have already done many of those in basic mathematics, under the name of function operations. किए हुए आपने function operations, क्या आपको याद आते हैं?
स्ट्रेच करना, उसको एम्पलीट्यूड बढ़ा कम देना, शिफ्ट करना,
मिरर इमेज करना,
Mirror
मिरर
करना।
इमेज अलोंग एक्स एक्सिस करना, शिफ्ट करना, उसको सब किए हुए हैं ना. You have already done that under the name of functions. So now we will quickly repeat in this section. We will repeat it under the name of operations, right? Operations that we do on various signals. Then we will go to some common signals. Some of the most common that we will look at: impulse, step, complex sinusoid. Okay. These three are critical to this course, and then we will look at these things. So some of these we will look at next time. Time shifting, I think you guys know very well. You've already done it under the name of functions, function operations. So what happens here in time shifting? Basically, कितनी shifts possible हैं? To the right or to the left? Yes. So if you are shifting to the right, xt becomes xt minus t. Yes. And if you're shifting to the left, it becomes xt plus t. For our point of view, the thing in the bold. इससे पहले जब आप when you were studying functions, maybe you're not doing any real interpretation. For us now, these are signals. Yes. So, what is it saying? Compared to the original, if you are shifted right, what is happening? What's happening in the bold occurs later than the original. Yeah. So if you were supposed to give an input at some time, then xt minus t is saying no, delay it, give it a bit later. Yes. Whereas xt plus t is saying no, give it a bit earlier. Yeah. So, and we need that. Or sometimes the system takes our signal and delays it. Okay. So that operation we have to be able to understand. I have like just a way of memorizing this thing, so we will see this next time, but a funny way is that minus leads to delay. Yes, and nobody likes delays. Okay. So sometimes you have to help your mind with these kind of things. What are they called? These are the tricks which help you remember something. Mnemonics. Yes, memory aids. So जरूरत पड़ती है from time to time. आजकल तो हम मोबाइल पे देख लेते हैं, एग्जाम के दौरान भी कुछ कोशिश करते हैं लेकिन just to have some things. Of course I'll show you how to mathematically check it. तो फौरन वो भी check हो जाता है, कोई बड़ा मसला नहीं है. But it helps to have some memory aids also, right? So we will do that next time. Now we will take quick attendance. Let's see.